All right. Angles of elevation and depression. And this isn't a very long set of notes. Really, we just have to learn what these two words mean and then use them in these sine, cosine, and tangent problems. So by the end of this lesson, you should be able to use angles of elevation and depression. All right, before we get into that though, real quick, do you know what this is? People say it's Sohcahtoa. And if you look at it, what does this have to do with sine, cosine, and tangent? Well, you've got sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And this is just a mnemonic device to help people remember what sine is, what cosine is, and what tangent is. So if you're starting a test and you don't have this, you can just say Sohcahtoa. And then like Sohcahtoa. Oh yeah, okay. And you can write it all out and you'll know what to do. Well, there's got to be a better way to remember this. So here's what I always like to tell students. Some old hippie crashed a helicopter tripping on acid. And it just helps you remember this thing. So that's what I use. There's a lot of other versions out there. I'll let you figure out the one that you like, but that's the one I have. Okay, angles of elevation and angles of depression. What we're going to do is you've got this little guy here. We'll make our stick figure. And he's standing around. And if he looks flat, it's like straight forward, that's 0. We consider that just 0. That's a flat line. That's there. But if he looks at something up, the angle right here, we consider that an angle of elevation. So you're looking up at something. Similarly, if he's here and he looks down on the ground for something, the angle on the underneath of that, we call that the angle of depression. Depression looking down, elevation looking up. That's almost the whole lesson right there. We just need to put things into context. Okay, angle of elevation and depression. We'll just fire some off here. So you've got all these objects. They're looking around like this guy. He's looking there. What would you call that? That's an angle of elevation. Well, for the hot air balloon, he's shooting straight there. If he looks down and sees the bottom of the tree, this is an angle of depression. This is an angle of elevation. Same with the bird. When he looks down there, this would be flat. The angle of depression is here. It's not here. And that one, it's here. You got to be careful with this. So make sure you're looking at the right angle. Okay, so suppose you stand 53 feet from a wind farm turbine. Your angle of elevation to the hub of the turbine is 56.5. Your eye is level at 5.5 feet above the ground. Approximately how tall is the turbine from the ground to its hub? So let's take a look at this. Get started. Scroll down just a little bit. Okay. Take a second. On your own right now. We'll have a little guy right here probably. Take a second. On your own. Stop the recording. Try this problem on your own. Okay, I did a little work here. We've got our guy. He's looking up at the wind turbine. If he was looking flat, that's what it would be. And his eyes are 5.5 feet above the ground from there to there. And this is a 56.5 degree angle. This here will obviously be a 90. We've got another 90 here. We want to know the whole distance from here to here. But before we can find that, we need to find just that little part of the triangle. So you think about Sohcahtoa. Some old hippie crashed a helicopter tripping on acid. What is involved? We already know our smiley face is, and it looks like we're using opposite over adjacent. So that looks like it's going to be a tangent ratio of 56.5. Messed that up. 56.5, which is equal to, what is the fraction? Let's see, we've got opposite, which is our x, over, what is it? 53 feet from the U here, 53 feet from here to here. So it's x over 53. Do a little cross multiply. 53 times tan, 53 tan, 56.5, 80. So we just found out that this right here is 80. We'll just say straight up 80. Maybe 80.1. All right. Is that our answer? We want to know how tall from the middle of the turbine to the ground. Well, we have to add on our 80 feet. So it was 80.1 plus another 5.5 to get a total of 85.6 feet. And that is what we get for our answer. All right. Oh, same kind of thing going on right here. Let's set up our problem. We've got a plane coming in. There's the ground level. There's the distance to the ground. We've got it coming in there. But the plane, if it flew straight and wasn't going down to the airport, it would be on this pink line. And it's Norway 17. The pilot must begin a 3-degree descent. So the question is, where is this 3-degree descent? And we look at this picture, it's not this angle. 3 degrees is really, really tiny. That's the 3-degree descent. And descending, starting from a height, 2,714 feet above sea level. But the airport is only at 1,007. And it's at 2,714 feet. So the thing is, they don't have to go all the way to 0 feet. Otherwise, they'd be deep, deep inside the ground. We need to know first, how tall are, what's going on here? What's our distance? And then we want to know, to the nearest tenth of a mile, how far from the runway is the airplane at the start of the road. So we want to know the ground distance right here. We want to know that right here. We could find any 3 of these here. But we need to first know this. Well, we got to grab our calculator and turn this feet into something. 2,714 minus 1,007, 1,707. All right. Now we got to figure out what angle to use. We've got to figure out, you could use this angle, we could use this angle up here, whatever we want. Well, I like to use, think we're at the airplane, so we might as well use that. Question is, what's this angle right here? It's not 3. It's definitely not 3. In fact, this would be a 90, take away 3. So we're going to use 87 degrees. Turns out this angle down here is 3 if you want to use the angle 3. All right, we've got our angle. We want to know opposite and we want to know adjacent. So that looks like what, a tan ratio? So let's say tangent of 87 degrees is equal to opposite question mark over 1,707. All right, we'll set it up, cross, multiply, divide. 1,707 times tan 87 is equal to 32,571. So I'll just type that in real fast. 32,571, 0.5 for good measure. And that is in feet. Let's check. Is that the answer we want? What do we need for an answer? To the nearest tenth of a mile. So we are not in good shape. We need to change this from its feet, which is what this is, but we need this in miles. Well, we're going to divide by, so we're just going to say divided by 5,280 feet per mile. So take that, divided by 5,280 equals 6.16, so 6.2 miles. There's our answer. Okay, going on. This is theta, if we didn't talk about it already. It's the Greek symbol for degrees. So whenever you see it, it means it's degrees. We kind of did one of these problems already. Be ready for that. Here's the Excel. We did this already. That was in the last quarter. We're on this section here right now. This has a lot of good warm-up practice. It has you set up ratios, set up, then you start to solve them, and by the end, you're solving all kinds of problems. All right, you can finish this chapter and get ready for the test.